Think about the last time you looked up at the night sky. The blackness of space adorned with the glittering radiance of countless stars. Peering into a telescope, you see distant planets, faraway galaxies. Now, imagine if rather than taking that in with your eyes, you were using your ears. Have you ever wondered what a black hole might sound like? What about Saturn's rings? What if these sounds were the only way you could understand what was going on in space? Sonifications allow the audience, including blind and visually impaired communities, to listen to astronomical images and explore their data. Today, we are going off the radar and off the visual spectrum to listen to the universe. We'll learn about how data from deep space telescopes is being translated into sounds. You'll experience celestial phenomena through an entirely new medium that may upend how we perceive and study the universe itself. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do. Welcome to Off the Radar. This episode might be one of my favorites. Today, I'm speaking with Dr. Kimberly Arcand. She's a visualization scientist from NASA's Chandra X-ray Observatory. Dr. Arcand uses her background in molecular biology and computer science with her current work in fields of astronomy and physics to find creative ways to translate scientific data into mediums that help tell a story. And today, she's going to share one of those stories with us. NASA was kind enough to share all of these sonifications with us. So as you listen to Dr. Arcand talk about these different images, you'll also be hearing them. Whether you're a scientist, a musician, or a space enthusiast, I'm hoping you'll be as fascinated by this project as I was. Please enjoy the sonification of space. Dr. Kim Arcand, I love this story. I love this project that you're working on or worked on, and I'm sure still working on. But I'm very, very curious about you. I want to start by asking you a few questions about your background, because this is a science project, but it's also kind of an art project. So I have so many questions about what your background is, what your education is, what your career history is.
Sure. My background's a little unique, perhaps. I actually come from a biology background and computer science background. But then I ended up sort of falling into a position working on the NASA Chandra X-ray Observatory, which launched back in July of 1999. And I joined the mission about a year before launch, which was a very exciting time to join a NASA mission because there's just so much happening, so much going on. And so my career has been sort of at the intersection of computer science and astronomy and data visualization and emerging technology.
So at what point did the idea come into play of turning images of space from telescopes into sounds?
Well, I first came across the idea because a dear friend of mine, Dr. Wanda Diaz, who is an astronomer and computer scientist herself, uses sonification as a process or as a tool for scientific inquiry. She is blind, and so for her, the data processing into sound is a way for her to study stellar populations, for example. And so I just thought it was an amazing way to be able to process data because our ears are sensitive in ways that our eyes are not. You can hear changes. You can hear small changes in your data. You can process through large data over time. There's all these different ways for you to understand data through sound. And so when I was working with some students on a virtual reality application of an exploded star, I wanted to try out using sonification as another layer of that virtual reality experience for accessibility, but also for experiencing it. I started working with some colleagues that I had met a couple years prior from a group called System Sounds, Dr. Matt Russo and Andrew Santaguida, who are musicians and sound engineers and experts in this process of translating data into something you can hear versus just something you can see, which is what I've been primarily doing myself up until then.
How does anybody decide what a nebula sounds like or what, these different images in space sound like?
Well, I think first it's useful to know that this is all a process of data translation, period, because Chandra, for example, is looking at the X-ray universe, things like exploding stars, areas around black holes and the like, and it's looking at X-ray light, which human vision cannot see naturally. So we have to process it into a visual representation of an object. But the data exists in that, set of ones and zeros originally, like that raw data, if you will. So you can process it into other forms as well. So we're not with sonification holding up a giant microphone to the sky. What we're doing is we're just taking that process of translation and moving it one step further. So instead of just an image, we're taking the image and then mathematically mapping it to sound. And that is definitely just like when we create the image and we're processing to smooth the data, to remove artifacts, to combine image data sets, to add color, for example, because again, X-rays are not something humans can see. We have to map all of those things to do that kind of image creation. It's the same type of thing in the sonification process. You are selecting which sounds to use based on the scientific information that you have, based on the data set that's been collected. If it is a spherical object, for example, we're going to want to move out either like a radar or from the central point. If it's more of a rectangular image, we might want to do a bottom to top or left to right kind of scan. If the object is very dynamic and changing, you're going to approach that data differently. So all of that scientific story that's captured in the data, that is what has to be like pulled out in bits and pieces, either through an image or through sound or through something else.
Is there some leeway when it comes to like artistic leeway as well that's factored into this? Because some of them, I saw one that was like a jellyfish. It sounded like it was in the ocean.
Yes, absolutely.
So I'm curious what kind of artistic fingerprint is in these two.
Yeah. So again, just like we have this process of creating an image where we're selecting, for example, colors, or we're prying apart the image based on that scientific story, right? It's the same thing with sonification. You're going to select sounds that have enough of a difference between them so that the listener can hear the various components of that data set. And we're also trying to select things that are pleasing to the ear. You have to pay attention to how quickly you process through it because you can only hear so fast. And if you're trying to build a mental map based only on the sound, you need a certain amount of time to do that. So speed choice is really important. So it's the type of sounds that you're selecting. It's the speeds that you're selecting at. It's how you're extrapolating all of that information out to make, hopefully, the listening experience be very useful, particularly for somebody who is blind or low vision, but also pleasing, right? Like in an image, we tend not to choose fluorescent yellow and neon pink and dirty brown, right? Because it's going to muddy up the graphic into something that's going to be very hard to look at and probably hard to differentiate. The same thing with the sound. You're trying to select sounds that are representative of the type of data and that scientific story, but you need to make sure they are unique enough and also complementary enough so that you can feel as you're going through a piece that they make sense.
It's wild as somebody who's not visually impaired. I think it's really hard to grasp that, but it makes complete sense when you explain it like that. Okay, can you take me through some of the images that are maybe differing and then also the sonifications that go with them? So what you may see when you're looking at something versus what you may hear.
Yeah, sure. Let's start with one of my favorites. It's one of the most scientifically important images I've ever gotten to work on. It's called the Chandra Deep Field South. And what happened is the telescope was pointed at a patch of the sky for like over 40 days and 40 nights, if you will. And it was about 7 million seconds worth of data. So the deepest X-ray image ever created. And what Chandra found in this kind of normal patch of the sky was thousands and thousands of black holes. And so the image itself, though scientifically important, is not the most visually arresting. It's like a black rectangle with a bunch of multicolored dots, like confetti that's been tossed onto it. And for me, it's always felt like the image didn't quite convey the excitement of what this actually is, that you're in a field of these supermassive black holes, and some of them dating back to like the very early universe. So for the sonification, the approach was to go from the bottom to the top to scan it, because that would allow two things. One, it is a taller field, so it lets you sort of go through the data at a nice pace, but also it would then allow you to use like a stereo type of effect, so that you feel like you're kind of embedded in this incredible population of black holes. And then for the sounds, it's a synthetic sound, but it's been sort of cut, like the image has been cut into the low, the medium, and the high energy X-rays, respectively, with the lower sounds and then the higher sounds mapped to that type of data. And so as you're going through it, you're hearing this beautiful sort of scene of young, massive black holes, and you feel like you're in it. And it just, for me at least, knowing how important that data is, the sonification, I think, communicates some of the excitement to it a little bit better than the image itself does alone, which I love. That's probably one of my all-time favorites, just because I feel like the use of the sonification was incredibly important, right? It wasn't just about making something pretty, but it was about communicating the science in a new way. Another piece that I love is one of the first ones that we ever did, and that one is the galactic center. It's another black hole, which theme of the day, I suppose, but it's a supermassive black hole at the center of our own Milky Way galaxy, and it's the inner sort of 400 light years around it. And it's this beautiful sort of landscape-shaped image combining data from the Chandra X-ray Observatory, as well as like optical or near optical light from the Hubble Space Telescope, and then some cooler infrared light from the Spitzer Space Telescope. And those have been colored, those different layers of data have been colored blue, yellow, and red, respectively. So for the sound, they were done sort of mapped, if you will, the same way, where the lowest energy data, the infrared, is like a soft piano. The mid-range data is like a plucky violin. That's the data from Hubble. And then the highest energy data, the X-ray data, is like this very sort of, it's a glockenspiel, so kind of xylophony, very, higher pitched. And the combination of those three different types of musical instruments just lets you scan through this data, where there is, by the way, it's like the Times Square area of our Milky Way galaxy, right? So lots of stuff happening, right? Like you're in Times Square, there's just energy all over the place, lots of noise, lots of everything. That's kind of what this area is like. So it's not just a black hole. It's all of these things, like large, massive stars, large bits of filamentary structure, stars hanging out together in pairs, exploding stars, you name it, all the stuff that's happening. And as you scan through it, you hear those moments where the infrared data is sort of leading the way, and then you hear that optical data kind of taking the lead, and then you get closer to the black hole and you're overwhelmed by the X-ray data, all of that high energy amazingness, right? And so having all of those sounds be distinct and yet complementary is a really great example of when you can hear those little moments of solos, and then you can hear these beautiful ensemble, like harmony-based moments where you can really feel like all of those different kinds of light are really working together. So it's a really great example of how using different sounds for each of those different kinds of light works very well to tell that scientific story.
You mentioned synthetic sounds. Were there non-synthetic sounds? Did you bring in musicians to work with at all?
Well, so most of these sounds, they're sampled primarily. So they're digital sounds, right? But Matt and Andrew are musicians. So they have also recorded themselves playing to get specific sounds before. And there is a data set called M51, the Whirlpool Galaxy, where the sounds are choral sounds. So it's like you're singing around this beautiful spiral galaxy with the bass, the tenor, the alto, and the soprano mapped to 4 different kinds of light, from the lowest energy to the highest energy, respectively. And as a former choir geek and band geek, I love that piece because it really does, I don't know, it's such a moment. It is such a moment, both cosmically with all of that incredible data, but also sound-wise, because it sounds like this incredible choir of the universe.
I was going to ask if you had any sort of musical background. I thought surely you must have at least some interest in music.
I do. Yes, I love to sing still. Mostly these days it's singing in the car or singing in the shower. But I have sung professionally, and I have been in a band and a marching band and all of that. So yeah, music is sort of in my bones. And it's a lovely way to bring a new element to this data that I've been looking at for so long, right? Like I have worked in this position for about 26 years, and I am continually surprised by what the sonifications can do to not only bring a new perspective to somebody who is blind or low vision, or somebody who's neurodivergent, or parents with young children, or teachers who are trying to help their students learn. Like we've heard all of those types of stories, and it's wonderful. But also to me, like to someone who is looking at this data, who's trying to communicate it in a different way, learn about it in a different way, talk about it in a different way. And the sonification just offers another channel in order to do that. Like I have noticed things in data sets that I've stared at for years because I've heard them for the first time and been able to recognize, oh, there's something happening here that I never paid attention to before, which I really kind of like.
Interesting. Have you heard from any astrophysicists that learned something new as well, that took benefit from this, even if they're not visually impaired?
So we have heard from scientists. So I think, as I mentioned, from Wanda Diaz, for example, as someone who uses sonification as a tool, I have heard from a number of different scientists who use sonification as a tool for research, that they are using these tools actively to conduct science. I haven't yet heard from anyone that's published a paper based on a new result from one of our sonifications or anything like that. But mostly these sonifications for us are just additional ways to be able to take this data and reach additional people with it, and hopefully provide a different kind of experience than they might otherwise expect, because sound, music tends to be very sticky in your mind, right? Like you can get a song stuck in your mind for quite a long time, right? And it has a very different quality in your brain than just an image has. And so I think there's just an awful lot of potential for this as an area of research, but also communications and storytelling.
Yeah, I was going to ask, is it art too? Is it something, do you think that there'll be a point where this becomes an installation somewhere? Or even I was thinking about, you know how they do like the movie and then the orchestra, they'll do performances where they show a movie and then the orchestra is playing along. Do you think there'll be like an orchestral version of this?
Yes. So we actually did have a young composer take the sonifications and create sheet music. And it's free on the Chandra website. So if there's any musicians listening, they can grab that sheet music for free and a score. And she created a 4-minute piece based around the galactic center that we had talked about earlier, but sort of bringing it down to the level where human musicians could play it. Because again, the data sonifications are based on data sets that are very rich, very detailed, and we're using digital assets to create them. So we can grab 1 million violinists and we can grab voices that can do almost impossible things. And it's not to worry, right? But if you want to translate it into something that people can play, you have to think a little differently. You have to plan a little differently. And that was something that we had gotten a lot of requests for. Pretty much anytime I talked about sonifications, there'd be a musician in the audience that's like, can I play this NASA data? And I'm like, I hope so. And yes, now you can. And we do actually have symphonies that have asked to play it, to do a world premiere. We have had interest from different music groups. We have had just such a surprise response to it. Again, not anything that I ever would have expected. Artists who are interested in trying to incorporate it into different kinds of displays, and museums that are trying to create exhibits around it. And I hope all of that happens, because I think it's a fantastic tool that we have at our disposal.
You've talked a lot about Chandra, but have other telescopes been used? I think everybody's so familiar with the Webb telescope and the images that come out of that being so beautiful. So have those been turned into sounds as well?
Yes. We actually worked with the James Webb Space Telescope team to create sonifications of the first few images that they had released about almost 2 years ago now. And those have been pretty popular as well. And we have sonifications with a bunch of Hubble data too. I think the sonification process, technique, method can only become more accepted and also just more widely used. And that's something that I greatly look forward to.
It makes me think of everything I take for granted now visually. And I'm curious, like the eclipse just happened. What does the eclipse sound like? Could we do a sonification of the eclipse? And what does that sound like?
Yes, we can. So a dear colleague of mine, Allison Barola, actually worked on that exact project. It's called the Light Sound Project. You can look it up. And it is essentially a small device that essentially translates the incoming light from the eclipse as it's changing into something you can hear. And it was incredibly successful. Her project is absolutely amazing, all like volunteer based and just wow. So yes, it's that kind of out of the box thinking that can really, when there are hard things to be done and when there are interesting roads to take, right? When you venture down one of those roads, like you can create something unexpected that can turn out to be very useful. And I think all the people working in sonification, it's a very wide field. People are using sonification in geology, in oceanography, in meteorology, I will bet, in chemistry, in biology, in medicine, other fields as well. And so having all of these different approaches to sound-based data processing, I think, can only improve and can only add to how we approach data. We did a survey on my team that looked at how people responded to sonifications, whether they were sighted or whether they were blind or low vision. And it was a very positive experience for all groups. And what was an interesting takeaway for me was not only that people who are blind or low vision were able to appreciate the sonifications a little more than the sighted group, but that the sighted group actually walked away knowing that people needed to process data of our universe differently based on their own abilities. And I thought that was a really exciting thing, that it raised awareness in general, that not everybody is going to look at the universe in the same way.
Yeah, it's kind of mind-blowing to think like the data's coming in and we're not seeing it. Like that's when you were talking about the translation, like, ooh, we don't have a one-up. It's just a different way of translating it. And we're all getting the same data, just very different ways.
Exactly. Yes.
Did anything like surprise you in the process of all of this?
Oh, the response really did surprise me. I had absolutely no idea that it would take off as it did. We did one sonification of a very, very favorite scientific result of mine, the Perseus cluster of galaxies. It was something I had worked on back in 2003 when it was the processing of the image, for example, with Dr. Andy Fabian and his team that had created the scientific paper. And I remember when we released it, I thought it was the coolest result because it was a supermassive black hole sort of blowing out into this area of hot gas around it, which causes these pressure waves, which are sound waves. And they calculated that the note that it was playing essentially was a B flat, about 57 octaves below middle C. And so that result had always been in my mind, right? This idea that there are these supermassive black holes out there in the universe, like divas singing a beautiful song, but too deep for any human to ever hear. Too far, not stuff between us and all of that, but too deep because 57 octaves below middle C is very, very low. And so that was one that was high on my list to sonify when we were working on this project. And we created a beautiful piece. We essentially resonified that note back up to something to human hearing. And so the image that has these ripples, which are the sound waves in it, processes that note and you can hear it. And it just became a beautiful piece. But the response to it was out of this world, if you forgive the bad pun. We had like literally 2 billion people potentially accessing this sonification, saying it sounded like something Hans Zimmer might make, that it would be like something like from a horror movie soundtrack. It was just a very amazing moment, right? To know that that sonification had impacted people in their daily life in some interesting way. So yeah, it's been a pretty fun journey.
So this is sounds. Are there other ways to take in science? I mean, we know visually, we know sounds. How else? What if someone is blind and deaf?
Yes. So the first type of data processing that I took outside of the realm of sight was actually 3D printing. So taking 3D models or tactile plates of these objects and 3D printing them so that you could use the sense of touch. And we did that project. We worked with the National Federation of the Blind to make sure the quality of those 3D models and those plates were really good, that it worked. And the response to that project was also amazing. And honestly, that was a big driver because when the pandemic hit, you couldn't be in the same room as someone. You couldn't access a 3D printer. You couldn't even barely ship things in the mail, right? You didn't know what to touch or not touch. And so that whole program had to skid to a temporary halt. And sonification was one of those things that we were able to sort of offer as a replacement. We now do all of them. We do haptification as well. So taking the data and processing it through, for example, like an iPhone or other kind of smartphone device, so that the vibrational response of the phone can be essentially mapped to the image as well. So there are all of these other ways of knowing. I will stop at smell. I will definitely stop at taste. For me, I don't think I want to smell or taste some of these things. It'd be like, I don't know, some of them might taste like rotten eggs and sulfur, who knows? But it is a fascinating thing to think about how we can process data in so many unique ways.
Okay, so there's a documentary, right? Where can we see the documentary? What's in the documentary? Should we listen to it first or should we watch and listen to it?
Great point. Yes. So we have a documentary that I worked on with my colleagues, Liz Landau, April Javette, and a host of other people as well. It is airing now on NASA Plus, which is a free streaming platform, no commercials or anything like that. If you look up NASA Plus in your favorite search engine, you'll find it pretty quickly. And it's called Listen to the Universe because it takes us through this whole process of working with my team, not only Matt Russo and Andrew Santaguida, but also Christine Malik, who came on as a consultant, I think about 2 years ago now, to work with us very closely. She is a consultant who specializes in visual descriptions and also does a lot of accessibility consulting. She's been blind since birth and has a wonderful and unique perspective on all of the sonification work and how we sort of process through it. So the documentary just kind of steps you through how we do it, who's doing it, and some of the results. And I think it's pretty fun. It should also be airing soon on YouTube as well. And it was just a fantastic project to work on.
I'm curious because I often see this like inaccurately displayed in movies, the sound of being in space. But space is quiet, right? So I'm curious if there was any concern about this causing confusion of what it's actually like to be in space.
Well, sound can travel in space, but what the issue is hearing, right? So for us to hear, there has to be a medium for that sound to travel to, of course. And, you're hopefully going to be safely encapsulated in your spaceship or spacesuit if you're doing any kind of traveling, because if you're out there, you need to have some kind of protection. So for us, there's really not much potential to hear any of this directly, even if it was in the right range of human hearing, just because of all of those restrictions. But there are actual bits of sound in space. It is possible for this to be confusing. And that was one of the things that our research found in the survey that we did, is that people could get confused if the sonification was separated from the text description that we had provided with it that says, this is a sonification that does such and such. So if you're coming across it in a different place where there is no description of what it is you're actually hearing, it can be confusing. But for the most part, we haven't found that to be an issue because it's easily correctable if you have the right caption.
I would love if you want to share any new projects you're working on or anything that we should be looking for in the future from you.
I think I shared them all earlier. Some of those are a little bit of a sneak peek because they're not all quite out, but we do have some very interesting artists working on different pieces with these sonifications. I very much look forward to those outcomes. So, but yeah, if you want to listen more, you can go to the Chandra website at chandra.si.edu or just put in your favorite search engine, Chandra sonifications, and you'll come across the whole library. They're all free. You can also find the 3D models if you want to try 3D printing. And yeah, it's a beautiful universe out there, and I hope we can all discover it.
Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes publish every Tuesday. If you loved this episode, please share it with a friend. We'd also love you to rate and review us on Apple Podcasts and Spotify. Let us know what you think of the show, and you can give me ideas for future episodes. A huge thanks to Dr. Kimberly Arcand from Chandra X-ray Observatory and NASA for providing all of the sonifications you heard today. As Kim mentioned, if you want to check out the full documentary, Listen to the Universe, it's available now on NASA Plus. For the National Weather Desk, I'm meteorologist Emily Gracie. Make it a great day.